Welcome back to Computer Science E1. My name is David Malin. This is Lecture 7, our lecture in multimedia. And what better way to start such a lecture than with a snippet of multimedia itself. I turn our attention to the above.
Hello, my name is David Malin, and I'm the instructor for Computer Science E1, Understanding Computers and the Internet at Harvard University's Extension School. You're watching one of our videos of the week. For more such videos or information about this course, visit us on the web at computerscience1.org. Enjoy the show.
Well, as you probably realize, this was an excerpt from the Teaching Fellows volumes of Videos of the Week. So if you haven't been following along from home already, do remember that per the syllabus, in addition to these lectures of videos and in the future, these videos of lecture and in the future of some sections and workshops, each week the Teaching Fellows have been doing a remarkable job, along with Chris Thayer, a former E1 student, in producing, scripting, shooting, editing, and delivering these videos to you, the students, via both the podcast that we've been distributing as well as via the course's website itself. In fact, if you haven't drawn your attention to such already, surf on over sometime this weekend to the course's website, you'll notice that the front of the website has recently changed, which is something we'll come back to shortly. But you now have two means of accessing the course's content, essentially. The old-fashioned way of the World Wide Web on the left here, and then the newfangled way on iTunes U, iTunes University, which again is a topic we'll come back to. If we do forge ahead to the course's website here, immediately at left, you will see that not only in CVS style, similarly is E1's website now sporting a Thanksgiving theme. How many of you noticed not only the Halloween motif, but some things fluttering around past few days? All right, so good. A little implicit test of who's been checking out the course's website. Next time you do, go on down to Videos of the Week, and what you will see is an increasingly large set of these videos. In fact, the Macs versus PCs one that you saw was way back from Volume 2. So if that's the first you've heard or seen that, do realize that you're a bit behind on some of this great content. And by no means are these videos required. They haven't been integrated per se to the problem sets, but what they are meant to be are supplements to these lectures, and particularly more focused than these lectures are. Realize, of course, tonight is about multimedia, a fairly broad topic. Our first two lectures were about hardware. Well, in contrast to those broad topics, these videos of the week focus in on very narrow topics in maybe 3 to 10 minutes maximum, and we sort of think of them as bite-sized pieces of knowledge or instruction where I can't imagine when any of you feels up to sitting down to 2 hours of this on your computer or your iPod, but certainly these, delivered by the teaching fellows, is something you can sneak a peek at during commercials, perhaps right after dinner or the like. So do check those out. You can watch them in two different ways. Not only can you download the QuickTime version, and we will define later tonight what QuickTime is, but you can also watch them right in your browser. And I think you've seen me do this once or twice, or you may have done this yourself once or twice, but if you simply follow the Flash version of the link, what you will actually get is these videos embedded right in your web browser, and for the most part, you won't need it.
Hello, my name is David Malin, and I'm the instructor for Computer Science E1, Understanding Computers and the Internet.
I do love the Macs versus PC video. It takes a sort of a strange turn, I think, toward the end there, but even I was smiling by the end. So that is the work of your teaching fellows and former E1 student. Recall a couple weeks ago, we passed around these surveys, which really just asked you for some candid feedback. It was useful, and we did process and absorb that and act on some of the suggestions, particularly one related to the course's website. A theme that came up 2 or 3 times in these surveys was that even though there's a lot of information on the course's website, there's apparently a real lot of information on the course's website, such that a few of you at least have felt a little overwhelmed perhaps on first visit to the website. And even though we try to categorize things nicely and alphabetically via the menuette left, and by design, nothing on the website is meant to be more than 2 clicks away. Choose a menu, choose the content. That's been the design. We admit that the menu, if nothing else, has been somewhat long, increasingly long. So we actually trimmed that down by a few options, merged some things, and generally just eliminated stuff that probably wasn't very much in demand. If you didn't notice a thing, great. If you haven't visited the website recently, do check it out, especially if you are among those who felt a bit overwhelmed. It should be a little more simple, and there'll be more content ripped out in the future as we focus in on certain aspects of the course's website, those strange Google ads that you seem to see at the bottom of the website sometime. More on that in a week or two. So 2 comments that I did want to relay verbatim, since they were quite memorable, if nothing else. So one of the questions recall in these surveys was, what do you think of lectures specifically? Well, this answer was, I have yet to nod off. So we appreciate that. That is the bar that we set for ourselves here. One other comment was fun, too. What do you think of lectures specifically? I enjoy free food and candy. Both of them very much about lectures, apparently. There is no candy today, but we can't have everything all of the time. But all that stuff is on sale now, I'm sure, at CVS. So with that said, let's forge ahead with our lecture on multimedia. And let's start perhaps with the easiest of questions, or the most obvious of questions, which is multimedia. What is it? Without looking at the yellow cheat sheets. Multimedia, what is it? Stuff that's not text. Okay, I'll take that. Let's see if we can elaborate a bit more. That's fair, though. Stuff that's not text. What else is multimedia?
Audio, and other components put together.
Ooh. Oh, Oh, an excellent definition, better than ours perhaps on the yellow sheet there. So it's a composition of audio and video and maybe text, but certainly text in a more animated way, a more dynamic way. You saw an example moments ago of multimedia in the form of video, which obviously also contained audio. What else specifically might you describe as multimedia? What kinds of files? What kinds of content would you say, hey, that's a piece of multimedia? Yeah. Like a JPEG. Or sound itself. We'll hone in on each of those topics more narrowly in a bit. When else in this course have we seen examples of multimedia? What comes to mind? Yeah. Videos. Be more specific. What have we seen? Yeah, good. So PowerPoint slides, we can chalk those up as a form of multimedia, especially if you've seen among the more stylistically designed PowerPoints that perhaps have less content and more swishes and zooms and fades and page tears. You can do a lot with PowerPoint, including audio and video. We tend to use them just for the static content up here. Anything else? Skype and Google Earth could be said to be a form of multimedia in that it's sort of interactive, it's graphical. Perhaps in the future you'll be able to do even more than that. But for the most part, there's no steadfast definition that we're looking for here. Multimedia, as the name implies, multiple media, audio, video, animations, text, but in a more interesting way than a simple web page, and so forth. So let's make this more real, especially since you probably see some form of multimedia every day. In fact, at work. This morning or this afternoon. Give me an example of a form of multimedia that you had on display in front of you. Anything at all? Yeah.
Different Swift files.
Okay, so different shockwave files? SWF files, shockwave files. We'll come to an example of one of those in a bit. What else? What did you have on your screen? What did you do today at work using your computer that you could say, yeah, you know what? That was an instance of multimedia. You got an Evite? Then, okay, multimedia, sure, because those things sometimes maybe have a little animation to them, perhaps. Well, what about a simple web page? How many of you, by a quick and easy show of hands, pulled up a web page today? All right, so odds are you were not looking at the most boring of web pages, but there was at least some graphic in that web page. So why don't we start here, perhaps with the most obvious, the most common form of multimedia, the graphics that you interact with, say, on the World Wide Web. What are these graphic, what is the format in which these graphics come? Pull up a web page, you see text, you see images, maybe on CNN site, maybe on Google site. In what format, so to speak, are those images? Digital photos, and let's be even more technical. I heard JPEGs, GIFs. All right, so let's start with those and see if by the end of tonight you can't tell a bit to your family or friends about each of these formats, which in and of itself isn't a particularly useful skill to be able to say the GIF format supports 256 colors, including interlaced frames as well as animation, but rather as you begin to progress and do things more technical yourself, whether it's in this course, playing around with Photoshop as you will in due time, or developing graphics, or just generally talking about something that you're seeing on the screen, or describing a problem to someone in a sort of tech support form, well, let's just see how specific you can get in detail. So a GIF is perhaps one of the most common file formats on the web. What do I mean by file format? Well, it's just the sort of definition of what it means to have an extension of .gif. So if you see a file like david.gif, well, that appears to be then a file in the GIF file format. Just to contrast this with something more familiar, if you have something like resume.doc, DOC, well, the file format in which your resume is what? Document, or more specifically, Microsoft Word's file format. So when we talk about file formats, we're pretty much talking about some kind of standard arrangement of zeros and ones inside that file. Who define the standard? Well, usually it's a person or a group of people or a company. For instance, Microsoft decided long ago that the .doc file format will be laid out in a certain way. And it takes Microsoft software or compatible software to understand that what at the end of the day are just zeros and ones arranged on your disk in the form of a .doc file, well, they have some special meaning, and you have to read them in a certain order. Similarly, in the world of multimedia, is a GIF just another file? A file on your hard drive comprising lots of zeros and ones, bits, but they're arranged in patterns that sort of define what it means to be a file format. So let's make this a little more, a little less abstract. So a GIF, and you can get these details not only off your cheat sheets, but off of the rapid-fire explanation I gave, are interesting in what sense? Just tell me something about a GIF. Ah, okay. Close. So there were some key components that you just said that are correct, but not quite. So a GIF is lossless. Let's come back to that. Let's come back to that in a moment. But a GIF is just a file format made up of zeros and ones, but it's a graphical file format, to be clear. All right, this is a file format for storing graphics on disk. Well, pretty much any image, any graphic these days on a computer is laid out as a rectangle of pixels. So a typical image might be, for instance, 100 pixels tall and maybe, let's say, 200 pixels wide. Well, what's a pixel? Who's seen a pixel today? It's a measurement. Specifically, it's one of those tiny dots on your screen. Ideally, you are not aware that your screen is composed of pixels, but if you put your eyes really close tonight, if you haven't noticed this before, put your eyes really close to your laptop or even your desktop's monitor, and you should be able to see that your screen is actually made up of hundreds or thousands of tiny little squares, dots, aka pixels. In fact, let's just relate this to our hardware lecture. When we have our old-fashioned computer here with a monitor on top of it, what were some of the common resolutions, did we say, for a monitor? What's a common resolution for a monitor? Anything come back to you? Or as of exam one, is that part of the semester over? Give me a resolution. Anyone at all? A common resolution. What is resolution? Well, that's just the number of pixels across and the number of pixels down. So what's the common resolution? Well, something like 1024 across by 768 down. Something like 800 by 600. Something even like 1600 by 1200. For those of you who have tackled the current problem set and have gone to a computer store, for instance, and have looked at the specs of your LCD display or your CRT monitor, well, you probably saw some mention of the default or perhaps the maximum resolution possible on that screen. So all this is saying is that if your resolution of your monitor is 1024 by 768, when you look at your screen, you are literally seeing 1,024 pixels across times 768 downward. In fact, if you want to put this into perspective or even play around on your own computer at home, on Windows, if you go to your display control panel, go to settings, and I may have pulled this up long ago, under screen resolution. You see exactly this. I can pull the slider and the next tick down changes it to 800 by 600. Oh, I wonder who that could be. Hello? Yes, just one moment, please. Oh, it's the pizza guy. So, no candy tonight, though. So, if I pull this slider to the left or to the right, that would effectively change my resolution. Unfortunately, this doesn't make for a great demo in class because these projectors are really designed to only work well with one resolution. But if any of you have ever connected a computer at some meeting at work or some presentation at school and things aren't quite working right with your monitor, and maybe when you plug it in, the thing goes blank even though you can see things here and you've hit the requisite keys to make things go there, well, sometimes, though not always, that's simply because your computer is trying to display a resolution that the projector doesn't support. That's one possible scenario. I'm going to leave things alone because it will mess up our projection if I change it now. But again, the takeaway is that you have a finite amount of screen real estate when you're looking at your monitor. And the relevance then to the world of multimedia is that multimedia, specifically graphics and videos, also have resolutions. And if the resolution of your GIF or your movie is bigger than that of your screen, well, obviously that's going to not be a pleasant viewing experience since you're trying to look at more pixels than you actually have room for on your display. Moreover, graphics are typically laid out in rectangles. So this graphic might be 200 pixels, dots across, 100 pixels up and down, but each of those pixels, meanwhile, can be of some different color. In other words, we have sort of a mapping of bits if you will. What ultimately comprises a graphic these days is just a whole bunch of dots, and each of those dots has a color. And the number of colors possible for each of these file formats differs. And that's what ultimately defines GIFs and other file formats. How many possible colors are there for the GIF file format? In other words, each dot in a GIF, how many different colors can it be? All right, good. So that was one of the things I rattled off earlier. GIFs are capable of, let's say, 256 colors. They are also capable of animation, and they are also capable of transparency. Well, what does this mean? Well, have you ever visited on the web the most hideous of websites where little things are dancing around and things are twirling, and it's clearly made by someone who was a bit overzealous when it came to the development of their site? Well, you might have seen things like, and I'm just Googling right now for animated GIFs, and I'm pulling up a site that, if all goes well, let's say food and drinks category, let's say barbecue and picnics, and if for some reason you would like a running puppy on your website, the only file format that you really have at your choice is the GIF file format, for the reason that it allows you to have animation. Now take a guess. How do animated GIFs work? What do you think's going on that gives it that animation? Yeah. Good. So actually, it's not a group of JPEGs going together. It's a group of GIFs going together. Each frame has to meet the same requirements. But do you remember as a kid perhaps those little flip books, the faux comic books, that if you flip through them really quickly, you get the illusion of animation because each page represented like a frame of a video, and if you flash them through your eyes quickly enough, you get the illusion of animation. Well, that's precisely how that dog is working. Someone has drawn maybe 4 or 10 separate images with each one. In each one, the puppy's legs are in a slightly different position. So when you play them again and again in a loop, you get the illusion of animation. What do I mean by transparency? Well, it would be nice if you wanted to put that puppy onto your web page, for instance, and your web page has a blue or a green background representing grass or representing, say, the sky. Well, things would start to look pretty ugly if the requirement for having animation on your page is that your animation has to be in the form of a rectangle. In other words, if you had a blue sky and green grass, and to put this puppy on the grass, you had to put a white rectangle with the puppy running inside that rectangle, sort of defeats the purpose of having some nice multimedia in the first place. So what's nice about GIFs, and in your section on Photoshop this coming week, you'll get to experiment with this if you so choose. GIFs also support transparency, which is to say you can specify that a certain part of the rectangle that your image ultimately is actually supposed to be transparent. And whatever else is on, say, the web page should be allowed to shine through. And this is in contrast with other file formats. What is perhaps the second or the just as popular file format on the World Wide Web? JPEG. All right, so a number of you rattled that off earlier. What is JPEG good for? Photograph. So how many of you have a digital camera, for instance? So for the most part, when you have exported those photos to your hard drive and then maybe uploaded them to Flickr or to KodakGallery.com or other such sites, odds are you are uploading, or at some point you're converting your photos to the JPEG file format. The reason being, JPEGs support millions of colors. Contrast that with 256. It's hard to capture the spirit and the color of an arbitrary photo of people and landscape and so forth if you only have a palette of 256 colors at your disposal. JPEGs, by contrast, then, allow you to have millions of colors, but they don't give you animation. They don't give you transparency. So it's a sort of trade-off. Yeah? Good question. So does making the background of this dog image transparent, does it perhaps affect the background that's behind the dog? If perhaps the dog itself has some white in him, you don't want blue sky or green grass shining through the dog? Is that the idea? So the way, long story short, that animated GIFs essentially work is you specify you essentially could fill the background of that dog with a random color, like pink, that simply does not appear in the rest of the image. And then essentially you tell the file format, you know what, everything that's actually pink, don't show pink, make that transparent. So in that way, anything that's not pink is going to be opaque, and nothing is going to be allowed to shine through from the web page's background. So that's a good question. And the nice thing is, and you'll get to play again with something called Adobe Photoshop if you attend this coming week's section, is that software makes these processes fairly easy. Making images these days is not like drawing a dot for every pixel, 200 times in one direction, 100 times in the other direction. Well, back to JPEGs for a moment and the relevance to today's cameras. Those of you with digital cameras, how good is your camera? Interpret that question as you will. What are the specs of your camera? 7-point-something megapixels. All right. How about the rest of you? Are your cameras also rated in megapixels? Okay. So you've all got megapixels, maybe slightly less than 7 of them. What does that mean? Why'd you buy all those megapixels? Okay, helps with the resolution. It is the resolution, in effect. But that's true. Why, in more technical terms, do you want more resolution to your photos? Why do you want more megapixels? Sharper images, more depth, you can enlarge it. That's exactly right. So think of it this way. If you took a photograph of something like the Grand Canyon, and your image, your camera, only supported photos of 200 pixels by 100 pixels, you could take the photo, and from a distance you could probably get a sense that this is a picture, albeit not very compelling, of the Grand Canyon. But suppose then you wanted to print that photo, and you've only got 200 dots this way, 100 dots that way. It's hard to imagine, even intuitively, stretching those 200 dots and those 100 dots to fill like a 5x7 photo, or even a 4x6 photo. What would happen, in fact, if you took an image that, in real terms is only this big on film, so to speak, and you try to blow it up to this size? What does it look like? It's very blurry, or maybe splotchy, where all those little square dots are now really big square dots. And that might make it look fine if you're looking at the photo like this, but you start to look up close and the thing just looks ridiculous. And think about the analog, by the way, to these graphical file formats in your daily newspaper. If you pull up the newspaper on Sunday from the Boston Globe, for instance, and look at, here's your excuse to regress for a bit, pull up the Sunday comics. Those comic strips often come in color on Sunday. But what do you notice when you look really close at colorful comic strips? For the most part, comic strips to this day are colored in the form of dots. From a distance, looks fine because your eye doesn't really distinguish that there's dozens or hundreds of dots there. You look at it up close, it doesn't really look so good. And that's sort of an analog to zooming in on the image and trying to print it at a larger resolution than it was meant to. So if you have a camera that only supports 200 pixels by 100 pixels, I apologize. Right? You can't buy cameras of this size. When the first cameras became popular, digital cameras became popular a few years ago, you'd get maybe a 1 megapixel camera. I, in fact, still have one that's 5 years old. It's 2.1 megapixels. But what does that mean? If my camera is 2.1 megapixels, what does that mean? It means what I just said. So yes, it means you can print them bigger, you can zoom in, you have better quality, but now relate it to this, like 2.1 megapixels. Well, that seems to be unidimensional, one-dimensional. It's the area. So when the Canon companies of the world and Sony says that this is a 2.1 megapixel camera, that essentially means if you multiply the resolution's width by the resolution's height, what you get is roughly 2.1 million. If instead we use Eric's camera, which is much newer clearly than mine, he has 7 some odd megapixels. That means that he's presumably got way more horizontal pixels, way more vertical pixels. And the beautiful thing about that is that you just have sort of a bigger canvas on which to draw that photograph of the Grand Canyon. You can crop out portions, and if you have enough of these dots, well, even if you just take a snippet of it, maybe that's enough resolution, enough dots to go to press with them from like KodakGallery.com. He can perhaps zoom in on just part of it too and crop away parts he's not interested interested in. So in short, if you're in the market for a digital camera, or perhaps finally realize, oh, that's why I paid for the more expensive digital camera, what you get is, one, more quality, but also sort of more flexibility, more discretion. For me, if I want to go to press with my photographs, I pretty much have to frame it the way I want it, because I don't have the luxury of opening that photo later on my computer, opening a program called Photoshop, tweaking things, zooming in, cropping out, because I just don't have enough dots, enough paint to play with and to manipulate. Yeah, question in back.
So I guess my question is that if you have a camera that has these 7 megapixels, you have a large width and a large height, but it would not be a situation where the pixels themselves are more narrow, for example. In images that, there are images where the pixels are actually more compressed. And so my question is the image more compressed, or is the image just a wider in scope?
The image, when you have more megapixels or larger resolution, the image is literally larger. There are more pixels going this way and more pixels going that way.
Wider lens?
No, you're simply getting so for instance, suppose I frame Ray here with my camera, and I'm using the real cheap camera with just the Ray, the only guy eating the pizza, mind you, right now. We'll do that in a minute or so. So if I just frame Ray with my really cheap camera, and essentially I'm shooting Ray and, let's say, Dan and Eugenia here. Well, 200 pixels across do I get? 100 pixels up and down do I get? Well, Ray, let's say, just fills the bottom corner of the photo the way I framed it. So think of it as I only now have one. Ray's trying to get out of the photo. So think of this as meaning that I only have, because of the way I framed my lens, 1 pixel to devote to Ray. And the other 199 this way and the other 99 this way are being used to capture Dan and Eugenia and part of the wall. Well, that's if I have really low resolution. So if I then look at that photo after taking it on my computer, Ray is in effect going to be represented as just one reddish dot. And that's it. But now suppose that I go with a more expensive camera. Same lens, I stand in the same place, I hold the camera in the same way. Now, because I have higher resolution, I get to now squeeze. They're not shrunk, but conceptually I get to squeeze more megapixels in between my left hand and my right hand, both horizontally and vertically, which means now in this bottom corner, rather than just having 1 dot, I have maybe a few thousand. They're smaller in this context because I've taken my image and said, you spend them this way. But now I have a few hundred or a few thousand dots so that I can capture more of what's going on here with Ray. I can see the dots on his shirt and the remaining slice of pizza on his plate and so forth. But even though I'm framing it this way and shrinking them conceptually with my hands, when you go to press, it's like printing a photo that's this big. You're just spending them, and you're zooming in effectively and spending those pixels in a more effective way. Yeah? Good question. Is it possible then to compress the image in certain places more than others? In theory, yes, right? If I'm not that interested in getting Ray in this photo, but I'm trying to be nice and keeping him in frame, but you know what? Spend most of the pixels on Dan and Eugenia. Let's just spend that 1 red dot on Ray. In theory, yes. But this is what a file format does for you. The JPEG file format, beyond just being a sort of standard for how the zeros and ones are laid out, it also specifies how you compress an image, what you do to compress an image. We'll come back to this in a bit, but the short answer is that yes, that's possible. You can compress different parts of the image in different ways, but that's not something that you, the photographer, tend to have discretion over. That's a function of your camera and its implementation of, say, the JPEG standard. I don't think I can hold you off any longer. Why don't we take a 5-minute break here? There is 6 cheese pizzas and 4 pepperoni pizzas, less 2 slices in back, along with some plates. Feel free to bring them to your seats, and we'll resume in a few minutes. All right, we are back. So lest you be wondering why we just served pizza, this is a thank you of sorts from the Harvard Institute for Learning and Retirement. Recall that this past Sunday, one of our E1-sponsored workshops invited a number of you, and as well as the staff and I, to work with some of the members of Harvard's Institute for Learning and Retirement. And we had a great time helping some of those folks learn how to master the Internet. 2 students among you, Dawn and Ray, were kind enough to join us, as well as Chris from last year. So this pizza is a thanks of sort, not only for their participation, but also just from ILR for their appreciation of how the day went. So thank ILR, maybe a few years from now if some of you choose to join them after E1. So just to put this into perspective, here's an example of a shot, not of the Grand Canyon, but let's say of a nice mountain and some trees. Well, suppose that this image is in the GIF file format, and it's a few pixels wide by a few pixels tall, maybe like 100 pixels wide by 300 pixels tall, give or take. Well, if this is in the GIF file format, that means that it is a bitmapped file format, which, as we said before, means that this image is made up of tiny little dots called, again, what? Called pixels. The problem, though, if you represent an image like this photograph here using a GIF file format or even the JPEG file format, because the JPEG file format, too, is a bitmapped file format. It's good for photos because each dot, each pixel in a JPEG can be any number of millions of colors, which means you can get much nicer gradients, whereas GIF only has 256 to work with. But both file formats are bitmapped, which means they're composed of pixels. The problem, though, to put this into perspective then, is if you try to zoom in on a bitmapped file format, be it GIF or JPEG, what you get is the effect there. What you see on the slide above you is a zooming in of the top of one of the peaks of that mountain. Because this image is composed of dots or pixels, and you only have a finite number of them, you can't zoom in forever. Right? You know how they, in Law and Order and CSI, when the security camera has taken photographs of like the bad guy fleeing the scene or of the license plate, and one of the cops will say, can you enhance that? Can you zoom in on that? No. Like, you cannot just zoom in forever just to improve the quality of the license plate that was captured across the street from a camera dozens of meters away. Right? If a camera is by definition just storing its photos in a bitmapped file format, which pretty much they do, whether it's GIF or JPEG or something proprietary for CCTV cameras, at the end of the day, you only have so much information there. And if it's not there to begin with, you can't zoom in and capture what information you would like to see. So honestly, the next time you watch Law and Order, CSI, and the computer tech and forensics is, can you just enhance that for me? Like, no, that is not possible to do ad infinitum. What you eventually get is a license plate that looks like that. Or there, for instance, is your suspect. That tends to be what happens in reality. Yeah? They claim that, yes. So yes, it is certainly true that with software and with intelligent software, you can interpolate information and you can kind of smooth out an image and maybe get a better sense of what the license plate is saying by sort of smoothing things out so it's not as blotchy as this. But at the end of the day, if you only have a fixed amount of information to start with, you can't come up with new information. And in effect, this is what these programs are doing, and it's an interesting question for court, because if you have computer-enhanced images, computer-enhanced is another way of saying the computer added information or changed the information that you were given. And while that might help in a practical sense, giving you the first 2 digits of the license plate, and that might be admissible, for instance, as an ID of the suspect, probably couldn't or shouldn't hold up if things are sufficiently blurry in the first place, or a good defense attorney could pick holes in something like that. But the takeaway for our purposes tonight is not so much why Law and Order, one of my favorite shows, and CSI aren't so realistic, but rather to at least relate it to, again, those images you've been seeing on your web page. Well, if most of these file formats that you see every day, GIFs and JPEGs, are bitmapped, well, what's the alternative? Are there file formats in which you can zoom in ad infinitum and get just a sharper and sharper image, even of just a small piece of that image? Well, yeah, there exist graphical file formats that are based not on bitmaps, horizontal rows and columns of dots, but rather vectors. Now, this is just a way of saying that you can implement graphics using mathematical formulae. In other words, rather than representing a circle of the sun as a circle of dots literally drawn in a bitmap file format like this, well, wouldn't it be better to take advantage of some of the algebra or geometry you might remember from high school and say, well, actually, I know that the formula for a circle is x squared plus y squared equals r squared, the radius. Well, wouldn't it be nice if in your graphic you don't represent circles as dots. You literally represent them with formulas as circles. Well, what does this imply if you desire to zoom in now on that sun? Well, if you're representing a circle with a formula, all you have to do is plug in bigger numbers to that formula, and you'll get a bigger but still perfect circle. By contrast, if you try to zoom in on a sun comprised of dots, what you start to get is what we saw a moment ago. You get blotchiness. So what you have here is an example on the second slide is a wireframe of sorts of some blocks of cheese. Well, there's no mathematical formula, to my knowledge, for a block of cheese, but you could certainly break it down into things like circles and triangles or fragments thereof. So what this wireframe is suggesting, that rather than representing this block of cheese, if it's in a vector-based file format with just dots, rather let's break each of the components of this picture, each of the shapes within the picture, down into some polygons, circles, squares, rectangles, straight lines, and so forth, and embed that information in our file format. So if you want to zoom in, all you do is scale things, and you scale them in a way that the quality, in effect, is preserved. Let's take a look at that in this example. A gentleman earlier mentioned the Shockwave file format, a file format ending in .swf. This is a file format for animations, essentially, which means it's not just graphical necessarily. It can also have audio embedded in it, but it's a file format in which an example like this is stored. So here is, it's already a little strange. Here is a bunch of Swedish horses, okay? So it is cool. So maybe you've even received this as an internet forward, yes? No? So right now it's very small, but arguably it's of good quality, right? It's not blotchy, and it looks like it's maybe, 200 pixels by 100 pixels? And where am I getting these numbers from? Well, what's my screen resolution now, if you recall from before? It's 1024 by 768, which dare say is the most common resolution today, though that's debatable as hardware gets better and screens get larger. So if I have 1024 across, well, it looks like it takes up maybe a third of the screen, so maybe it's 300, 400 pixels wide. That's where I'm coming up with these numbers. Well, it looks pretty sharp. Suppose then I want to zoom in. It would be unfortunate if these cute little horses all of a sudden become blotchy and more square-like our mountaintop does, but it turns out that they don't. In fact, this probably looks even sharper now because we're really spreading out how the dots are being spent on the screen or how they're being computed. If I zoom in even further, making this full screen, it's a pretty sharp image. In short, even if I had a bigger monitor, I could keep scaling this again and again and again, and it would still, the lines, the curves, the colors would still look just as sharp because these horses and everything around them is being represented somehow or other mathematically, not with just dots. Now, this in and of itself might be cute. Wait till you see this. How many of you have seen this? 1, 2.
Boom, boom,
Turns out this is an a cappella quartet.
boom, boom,
So to put this into technical context, Shockwave Flash is Shockwave is a animation file format. Again, supports audio, and it also supports interaction. So if you've ever been to a particularly sexy website, which doesn't just have graphics and text, but rather if you click something, something swooshes away, and maybe something zooms in. If you visit a lot of fashion sites like Banana Republic or Gap, or if you visit a lot of furniture stores, tend to have websites based in Shockwave Flash or similar technologies, they're interactive. So I clicked on that horse to get him singing, and I'm going to try to time this correctly. I got it wrong. That's not bad. Okay? That's wrong. Try again. Not bad so far. I think we have to add the soprano, perhaps? It's so simple, and yet it's funny. That's it. That's all this thing does. So anyhow, we'll make a link. This will perhaps be one of the most popular links visited after this lecture. But that is an example of a file format that doesn't just use bitmaps. It actually uses vectors. And by vectors, we mean mathematical formula. Mathematics in some sense, such that the visual upsides of that usage are quite clear, or hopefully more clear from an example like that. Well, Where else do mathematics come into play? Well, this isn't a graphics class, and so we won't go into detail as to how the latest and greatest video games are made. But certainly, if you've looked over your kid's shoulder at the latest PlayStation game or GameCube game or even PC game these days, these graphics are far beyond the pole position and asteroids and Donkey Kong that at least I grew up with, which were very much more bitmapped types of games. Well, these are three figurines here that perhaps just capture the spirit of how some of today's games are implemented, whereby characters are not just implemented like Mario and Luigi were in the first Nintendo as just a bitmap of colors that collectively represented Mario's face and mustache and hat and clothes, but rather they're represented more clearly as a collection of polygons, of mathematical shapes. The beauty of that is that if you want to implement a game where the player can go anywhere on the screen and can do different things with his arms and legs, and you want to have the actual illusion of movement, well, it would not be ideal if you had to, just to get your player to do this, store a graphic that using pixels that precisely depict the player in this way. If instead you wanted your player to be able to lift his hand slightly, you don't want to have to recreate an entire image, a GIF really, or a JPEG, just to capture that slight bit of movement. In short, you don't want to create a sort of flip book of all possible permutations of characters on the screen and physical locations, because if nothing else, you would need a DVD or more, multiple DVDs to store all of those darn images, certainly at the resolution that people expect on today's games. A much more efficient and faster way of storing information then tends to be using mathematics of some sort, linear algebra and other things that you've probably happily forgotten from years ago, but that at the end of the day help you model things in a way that's much more scalable. And so if you want your character to move into some direction, that essentially means that your video card or your CPU simply has to perform some mathematics and create on the fly the representation of that character in his new position. In short, a lot of today's craziest video games are developed in this much more dynamic rather than static way. It's fun, perhaps, rather than playing one of today's latest and greatest games, which you yourselves might own, what I thought I would do is draw our attention to the course's website. There's another under-publicized link there. Perhaps you have stumbled across it late at night when looking for something better to do. But if you click on the course's website, the link entitled Games, what you have here is a little archive of free games that are actually implemented in the, I think the Shockwave Flash file format, which was developed by Macromedia, is now owned by Adobe. And you have some examples of games here from yesteryear. In fact, we seem to have Asteroids up top, Donkey Kong, if you're familiar, Frogger, Moon Patrol, Pac-Man, Pong. It doesn't get any simpler than Pong, really. Space Invaders and Tetris, which is a little newer. From the audience, which was your favorite game from yesteryear? Tetris. Space Invaders. I heard Frogger is the favorite game. Who said Frogger? Can I entice either of you to come down for a moment and show us just how good you are at Frogger? That's fine. Would you like to come? Remember, up, down, left, right. There aren't 20 buttons in this game like today. Can I entice anyone to come down here and show us how good you are at Frogger? Yes? No? Come on. All right, come on down. What's your name? Heather. So Heather, I guess, do we get to type? Oh, sorry. Yesterday's games only supported 6 character names. Okay, so you're this frog here, and you can use the arrow keys, I think, to move up, down, left, right. Have you played this before? Oh, all right. Try once more. Redeem yourself. Make us proud. Once more. Extra life. Once more. All right, once more. Let's end it with a positive note. No, that's fine. You're just getting worse, it seems. Right? All right. Very well done. Congrats. All right, so there's plenty of other games there that you can play with later, but what are some of the takeaways? All right, can we spin this as an academic exercise? So what was interesting about that game in the context of all this stuff? All right, it's definitely bitmapped, right? I made the thing so big on my screen that you could see that everything was the result of putting little squares of color together, green for the case of our frog. What else did you notice? So very flat, two-dimensional, right? There's animation, but when Heather was hitting the up key, that whole GIF or whatever it was back in the day was just moving entirely up, a few pixels. It wasn't gradually sliding. It's certainly much easier and much more efficient to just have these things jump across the screen. And fortunately, the frog's moving relatively short distances, so it looks like he's just taking one fluid step, when in reality, he's hopping from one step to the other. And there's nothing in the middle. Anything else come to mind? Well, this is good that we had a note of video there. Let me ask Dan to come up and, as we proceed, to connect his Macintosh as so we have the duality, as we promised in our introductory video earlier. For a moment, though, there was a question from before about compression. And I said, we'll come back to that later. But the nice thing about these graphical file formats, both GIF and JPEG, is that they are quote-unquote compressed. Well, what does that mean? Well, what does it mean to compress a file? To make it smaller. So what are some of the considerations there, right? Like I could make a file really small. I could make your resume really small by Control A and then delete. Is that compression? Right, well, I mean, it is, but it's what we would call lossy compression. Lossy, and this is a technical term, lossy in the sense that, yeah, you're making the file smaller, but by throwing away information. So it's sort of a corner case in that, yeah, you can make the file smaller if you get rid of the file's contents altogether, but that's sort of an extreme case of what is in fact done today. Well, what rather do you want to keep in mind? When you compress a file, what are your concerns then? Ideally, you want to keep all of the information. Unfortunately, that seems like a catch-22. You want to use less information, fewer bits, to represent the same amount of information. That is to say, if you don't want to lose information, you've got to keep it around. Well, if you want to keep all of your information, what could you possibly throw away? Becomes the question. Well, and actually, if you want to sit for a moment and rather than stand there awkwardly, we'll finish this. Don't worry, the Mac will be back in a moment. So how can you do it? Well, consider this. Here is a flag of Germany and a flag of France. Suppose that I store both of these images as GIFs, which means, again, they can only have 256 colors maximally. That's fine. We only need 3 for each of them, so that's not a constraint. They can only be bitmapped, therefore. So essentially, these flags, though you can't quite see it, are made up of a bunch of little dots, left, right, top, down. And suppose that the file on top is, suppose that it's, let's say, 300 pixels by 200 pixels. Well, if it's 300 pixels by 200 pixels, then what do we have? So 300 by 200, what's the total resolution? Or how many pixels are in this flag altogether? All right, so 6, 1, 2, 3, 4. So 60,000, right? It's kind of impressive that you go from 300 across, 200 down, and you get 60,000 pixels, but that's how many little dots are making up that, say, German flag and France flag. So the question on the table is, can you represent these flags in with the same aesthetic effect, but using fewer than 60,000 bits? And just to put 60,000 pixels. So to be clear, each of these flags is made up of 200 dots horizontally, 300 dots horizontally, 200 dots vertically. Each of those dots in turn has a color. For instance, in Germany's flag, most of the pixels all the pixels up top, the top third, have the color black. Okay, all the colors in the middle, red, and then yellow. So you need to remember the size of this thing, the shape of this thing, the colors being used. So what can you throw away? Can you use fewer than 60,000 pixels to represent Germany's flag? True. Yes is the answer. You get the harder one. How? Okay, so a 3 by 3 image, that would change, that would distort. 3 by 6 would distort the dimensions too. So can you make it smaller? You could certainly in this case. What do you mean by smaller? Sure. So you could certainly just make the image smaller so that therefore you need fewer bits, but I would say you're essentially telling me to delete parts of your resume. Right? Make this file smaller by make the file size smaller by making your flag appear smaller. But my goal is to put this flag on Germany's homepage. Right? www.de is where I want to put this thing. So I want it that size. I want it really big. I can't cheat and save space by just making the flag smaller. Let's go to question back or suggestion. Okay, good. So a slightly more mathematical approach. In short, and I'll tweak this just to lead us in the factual direction. So keep around information for some of the pixels. For instance, the leftmost row or leftmost column of pixels. So you've got 200 pixels on the vertical there. So that means you've got like 66 black pixels, beneath which are 66 red pixels, beneath which are 66 yellow pixels, and then plus something else. Right? That gives us 200. So what if we just stored that column and then said, you know what, multiply this column by 300? Well, would that do the trick? Well, if you think about it intuitively, there's a lot of redundant information in that flag. What is redundant about the flag? It's just solid bands of color. But in effect, with GIF or JPEG, as we've defined it thus far, you're essentially saying, if you're storing it as a bitmap, make this pixel black. Make this pixel black. Make this pixel black. And you're doing this 300 times. Then you're going back here, stepping down this way once, and doing it 300 more times, eventually saying, this one is red. This one is red. Then eventually you get down to the yellow. This one is yellow. I mean,
you could just scale the borders, and you just document all the borders and as scaled vectors, and then you just multiply those to make them larger.
Good. That's essentially the answer. You retain as much information as you need, and then you multiply it by some factor. And this, in fact, is how GIF works. GIF, in contrast with our Microsoft Word proposal earlier, is a lossless compressed file format. Lossless, as that word implies, when you compress it, you do make the file size smaller, but the upside is you do not take away from the quality of that image at all. Well, how is that even possible? Well, in effect, all of the GIF file format needs to remember for Germany's flag is that the leftmost column is 66 black pixels, 66 red, and 66 yellow, then one extra pixel left over. Then multiply those by 300. So now, in effect, I only have to say this pixel is black 66 times. I only have to say that this pixel is red 66 times, and then the same thing for yellow, and then I, in fact, just shout out, repeat 300 times. And you can say that, just as I could verbally, so much more efficiently than you could by just repeating yourself 300 times by 200 times. Contrast that now with the flag of France at right. Taking on faith that the GIF file format pretty much works as we just described, defines as many pixels as are necessary vertically, and then says repeat. Does France's flag compress using GIF better or worse than Germany's flag? Worse. Okay, you say worse. Why? Takes 300 instead of 200 what? Right, because the colors are not contiguous throughout, you essentially have to say, this pixel's blue, repeat 100 times. This pixel's white, repeat 100 times. This pixel's red, repeat 100 times. Contrast that now with the story over here. This top left pixel's black, repeat 300 times. You're done with that row, saying a third as many sentences. And we can make this, we can confirm as much in tonight's GIF directory, which is linked on the course's website. Here are precisely these images. If I go to details mode, notice how large is the France flag, FR large. 5 kilobytes. It's a little small on screen. How big is Germany's flag? 3 kilobytes. So we have a bit of empirical evidence here, too, that the mathematics do, in fact, corroborate the conceptual explanation we gave a second ago. Yeah?
So it only goes from left to right, then, as far as compressed. It can't be top down.
Correct. So the GIF file format is designed to read this left-right manner. Let me pause for a moment. Let's sit still, unless you'd like to grab a piece of pizza, and we'll swap out tapes. But let me take a question or two offline now. What about pings is an excellent question. So we looked at GIFs, JPEGs, also on your yellow cheat sheet, and also on the World Wide Web is this third file format that's not nearly as popular as these two, but in a sense is better, and it is called the Portable Network Graphic format. PNG is its file extension. This, too, like JPEG, supports millions of colors, but it is lossless. So think of this sort of as an amalgam between what GIF and JPEG offer. Moreover, ping is not encumbered by various patent issues that the company that invented the GIF file format for a while stomped their feet about people using it without paying royalties to them to output these GIFs. So ping was partly a response to that. That particular issue is not so hot anymore. So the short of it is that GIFs and JPEGs remain the most popular file formats today. And if you would like even more technical detail on any of these three, and actually a really good resource would be just the computer dictionary link on the course's website. Type in PNG, type in GIF, type in JPEG, and you'll get back some more technical detail from the Webopedia site as well. Well, how else might you compress information, or what are some of the other considerations? How about this apple? This apple is on a blue background at left. How much of that information do you need to keep around? Well, just to reiterate what we considered verbally with the flags, you pretty much only have to keep around as much information as is currently in the right-hand version of this image. Right? If you're saving this as GIF, you've got to remember a column of blue, and then in effect, and the details of this are not so important for our purposes tonight, but in effect you can say, you know what, anything that's just white, fill it in with blue. And so with a graphical file format, can you use tricks like that as well? Are we losing any information if the right-hand version doesn't represent the visual result of compression, but this is depicting how much information we're physically storing in the file? Can you reconstruct, using that much information at right, the original image, is the question. And the short answer, using the heuristics we've discussed, yes, because we've remembered just enough, especially in this context, if we advance to the level where we can say, you know what, don't just repeat horizontally, go fill in anything that's white with blue. That would be sort of a neat trick to employ as well. Well, graphics are one thing. We've seen a tad of audio. We'll come back to that. But video is certainly in vogue these days. And as bandwidth speeds increase and people have faster connections to the internet, and as disk storage gets even cheaper, you see sites like Google Video and YouTube, the last of which we've pulled up an example a couple weeks ago. What video did we watch on YouTube? Yeah, it was that hard drive where some guy had opened up his hard drive but still left it in operable condition and deleted all those files. Well, that was an example of YouTube. YouTube uses a file format called Flash Video to store all of their videos. What this means for you, the user, is that the wonderful thing about YouTube and, say, Google Video today, and even E1's website, if, like before I did, you click the Flash version of our videos of the week or the lectures, you don't need special software. Because where did that video of the week start playing? Right on the course's webpage, right? There was no prompt to say, do you want to open this or save this? There was no new window that came up. It was just the course's website with the video embedded therein. Now, that was a bit of a white lie. You do need special software to play Flash videos. You do need special software to play Frogger, as we did before. But According to a company called Adobe, 97.2% of computers on the internet today are thought, according to their marketing folks, to have what's called the Flash player installed already. What you've seen happening these days is when you buy a Dell or you download software from Yahoo or Google, a lot of these companies tend to embed other people's software into your computer for you, the result of which is usually kickbacks of some sort or some financial gain for them. But the nice thing about this, because the browsers have done this as well, most of today's browsers, if you install IE or you install Firefox, they too come with support for Flash. That is to say, they come with the plugin, quote unquote, that allows you to play those videos inside of them. So back in the day when this was not as popular, you would instead, upon visiting the course's website, if you don't have the Flash plugin installed, you'd get like a broken icon, or you'd get a prompt saying you need this plugin, do you want to install it? These days we've reached a point where so much stuff do you get for free automatically when you buy your computer or download some other program that you have the illusion of everything just working seamlessly. But contrast that with, for instance, QuickTime. QuickTime is the file format in which we played Dan's soapbox at the start of tonight's lecture. And if you recall, we did need a special player for that. A new window came up, and that was the QuickTime player made by Apple. QuickTime player, by contrast to Flash, does not come on every Windows PC these days. Rather, if you have wanted to download the course's podcast, you may have, in fact, had to yourselves go to apple.com and download iTunes or QuickTime. Funny thing is there, even Apple does it. You download iTunes, guess what you get for free? QuickTime, right? So good and bad things about that, but for practical purposes, it tends to be a useful thing, that this stuff just seems to work. So why don't we motivate this foray into video by pulling up a video? I know what's about to happen, so I don't want to be the guy on video, or ironically, but I need another volunteer who wouldn't mind being not only on video, but also on video, and ergo video. Come on, anyone at all. All right, we go through this every week, and then there's always someone that volunteers. Come on. It's a non-speaking role. All right, come on down, Dawn. All right, Dawn is going to stand in front of Dan's MacBook Pro here, a nice fancy Macintosh laptop. You will see the effects of what we're doing, but we will see them even bigger up here. I'm going to have Dan use his Mac Savvy to touch the right buttons. This is obviously a web camera of sorts built into Dan's laptop. You might use this for video conferencing like we did with, albeit in one direction, with Victor of the Typical PC User podcast a while back. Dan is going to use it as an example not only of just multimedia and video, but what kind of software exists today and how fast processors are today such that they can render the images of Dawn you're about to see in real time. There was a time where all of these morphing examples, does anyone remember the Michael Jackson video from 5-10 years ago where each of the actors in the video morphed, and by that I mean sort of blended into one another? That, as I understood it, took weeks, if not months, to develop on computers because it took so damn long for the computers to generate all of the intermediate pictures. What you're about to see is what was now possible in 2006. I give you Dawn.
So this is good for anyone who didn't happen to go trick-or-treating, I guess. Let's see, here's the fun one. So like I said, this is good for anyone who didn't get to go trick-or-treating. So just move around. You can make some great faces. Okay, wait, right there. Hold it. Wait. Move to the left just a tad. Okay, let's see. All right, wait for it. Wait. Oh, there it goes. Okay, it takes a photo. Okay. Let's see what else we've got here. We have, fisheye.
Oh.
Yeah, if you get really close, you can make your nose quite large. Yeah.
Oh, yeah. Yeah, let's do that.
Well, let's see. There's probably a better one. Oh, here's a good one. Bulge. Yeah. So, one more photo, I guess.
Okay.
We'll put these on the course's website after, perhaps? Yeah.
Yeah, thanks for that.
And we do actually have one of David here that he so kindly took for us. I think he was going for the Jay Leno look, but I'm not quite sure.
We'll get to privacy and security in a couple weeks. I had no idea this photo was being taken when we were experimenting earlier. But I guess in fairness, we'll put that on the course's website.
Yep. So the question was if you can change an artwork in the same way that you're changing these photos. And basically all there is just the camera right here. So anything that you can hold up in front of the camera, you will change with these different effects. So there were color effects in this first, where was it? There was color effects in this first section here. So if we held up, for example, David's notes that we have, we could just hold it up and change the coloring, or we could go into the twisting effects and the various other things, and we can actually see the different, in real time, the different effects that we have. So yeah, it's not really the highest quality. Basically what you see for the resolution, this is about 640 by 480. So it's just probably a shade over 1 megapixel, the equivalency of the camera.
You know, this is really disturbing. The woman on the overhead is...
Okay, here, we'll make it a little bit better. Normal, okay. This program comes with new Macs that have the webcam built in. This includes the laptops and some of the desktops as well. It's in the applications.
Can you layer over effects? Color?
No, you cannot layer effects. Just one at a time.
Other questions? Well, a big round of applause for our guinea pig here. Thank you. So on this same note, you'll notice that distributed tonight is problem set 5, multimedia. This is a particularly fun problem set in that it's very hands-on and graphically where is this? Oh. And graphically oriented. Among the tasks ahead of you are the following. On top of the course's website, as of yesterday, is a big turkey. And you may have noticed for quite a while, if you click on the banner at top left on the course's webpage, it actually changes automatically for you. Now we have gobble gobble 2 turkeys. If we click it again, we have a dog dressed as a Native American and a cat dressed as a pilgrim. So I wish I could say this was our handiwork, but these are actually images developed by last year's student body in E1, because if you've skimmed the problem set being distributed tonight, the first challenge of this problem set is to task you with learning a bit or applying a bit of knowledge about Adobe Photoshop, which though we try to be software and platform independent in this course, hands down the de facto standard for graphics design these days is Adobe Photoshop, which is a very expensive program normally, but for which there exists a free trial that you can download off of Adobe's website. We have a link on our own course's website under software and under the multimedia category, and it works perfectly for 30 days, after which they try to coax you to buying it. But with your Harvard ID numbers, you can actually use Harvard's version of the software too, so long as you're registered in or affiliated with the university, and so long as you have a network connection to the campus. This week's section, if you are the sort who does not like dabbling on your own or feels a little overwhelmed by pulling up a new piece of software a la Google Earth and learning yourself how to manipulate images, this week's coming sections will focus in particular on designing GIFs, JPEGs, and PNGs using Adobe Photoshop. And these will really be hands-on tutorials, hand-holding tutorials on using software like Adobe Photoshop. And this problem set will invite you to apply that newfound knowledge to the design of your own very banner. And in fact, what we will do after the images are all submitted as part of the problem set is your own work will be exhibited for a number of weeks on the course's website. And if you get tired of looking at someone else's image, right, you can always click it and change it to your own. And if you don't click the image up top, it actually changes automatically using something called cookies, which we'll come to in our website development lecture, to actually remember which one you saw yesterday so that you don't show the same one again. Moreover, as extra credit in this problem set, you'll notice specifications toward the back of the shape of a mouse pad. So each semester we have a contest of sorts whereby for extra credit, any number of students are welcome to submit candidate designs for this semester's fall 2006 mouse pad, so long as the mouse pad somehow embodies the theme of survival of Computer Science E1 per the specification. We will then enter you in a voting process that we'll have in a few weeks after this problem set is submitted. You, the audience, will vote on your favorite design. At the very last lecture, you, and as well as our distance students, who we'll take good care of via postal mail, will walk home with a souvenir of sorts from E1. As if the candy and pizza weren't enough, we'll give you something non-edible to remember the course by, and that will be the mouse pad that wins the popular vote. And that'll be coming up in the form of this problem set 5. Let me also draw your attention to the blue handout tonight, which is the final project, which, per the syllabus, challenges you to develop your very own presence on the World Wide Web. Funny we should hand this out now, given that you have yet to see your website development lecture or content thereof. That's okay. The first task in the final project, the so-called Part 1, tasks you with thinking about what kind of website you want to design. And fortunately, the only prerequisite for answering this part of the problem is, what sites have you visited before? What do you like? What would you personally like to do? Literally at the end of this course, you will have your own presence on the web, something of the form www.davidmalan.com, but with your name inserted. Or you can have it be something completely random, like www.myhomepage.com. I would wager that both of those actually are already taken. And as we mentioned in this part of the project, perhaps, dare say, the hardest part of this project, frankly, because the rest is all fun. This part's the frustrating part, finding a domain name that someone or some squatter hasn't already bought. But we don't constrain you to only choosing a .com. You can choose a .net, .org. Heck, you can have, danarmendariz.tv. if you wish. I would wager that that one is still available as of now. With that said, though, there will be the cost of buying a domain name for the period of a year is like $10 or so, and that it's all spelled out there. And we would ask that you take care of that part of it. There are alternatives if you'd rather not incur the expense, but we, E1, the course, will host your website for you up through spring semester. So we will provide you with an account. We will provide you with an email address of the form username at davidmalan.com, but substituting your domain name, of course. So literally, at course's end and through May, you will have your own presence on the web. We'll provide you with the disk space. You'll get a gigabyte of storage, especially, which is very useful if you want to have, say, a website of photographs of your recent trip. Right? Gone are the days where people come over and watch slideshows of their latest trip. You can just put that on the web and email all of your friends those photos. This would be a wonderful application for the final project to do something like that. Really, the sky is the limit. But more on that in technical detail in our next lecture. The first part of this project, which is due at the end of November, invites you to start thinking about your website and also to choose your domain name, because we'll need a week or so to set up on our end all of your website domains so that you have some place to put all of your content when you start writing HTML yourself. So any questions on that? Just let us know. In the meantime, any questions on this or another thing? Yes? No? Yes? No? All right, so let's go back to where we began. If we pull up the very first clip from tonight, this was this so-called QuickTime video. QuickTime is a video file format that was developed by Apple. If you have a Macintosh these days, you already have support for QuickTime installed, which is to say, if you visit some website and they say, hey, download this video, it's in QuickTime format, all you have to do is download that video, double-click it, and it will start playing. If, by contrast, you're on a PC, odds are you first have to go to apple.com, download the software, install it, and then you can double-click on the .mov file, which is the file extension for QuickTime movies, and then it, too, will play. This software here that I just pulled up is the so-called QuickTime Player. It's the software that Apple developed, and if you want to play QuickTime movies, you need this software or compatible software. When I click play, what it starts playing is that video of the week that we began tonight doing. But rather than play this again, I'm going to go up to its window menu and choose Show Movie Info. And there's a bit of interesting information here. It's a little small for you to see, but is it big enough to tell me what the resolution of this video is? What's the resolution of this video? Current size. That's the current size. So that's not so much that's not its native resolution. What it's built-in resolution. It's the 320 by 240. So 320 by 240 is the resolution of this thing. Ignore, for tonight's purposes, the 356 by 240. But 320 by 240, that should sound somewhat familiar, at least if you multiply that by 2. What do you get if you multiply those dimensions by 2? 640 by 480. So we're back to a sort of 4 by 3, or roughly 4 by 3 aspect ratio if you do the math there. Which is to say that these videos that we're distributing are actually pretty small. Right? When we blew up those Swedish horses, they filled the screen quite nicely and quite clearly. By contrast, if I blow up this video, the projector doesn't really give you a sense of just how blotchy things get, but can you already tell that at this resolution the text becomes a little blurry? And if we say fast forward to this, well, this stuff's not bad. It's pretty clear, but it's also it's a little, well, we'll pick this one randomly. So tell me about this photo. Critique this photo, ignoring the subject. But talk to me in technical terms. What's interesting about this? Anything? So the outlines of Ray, like of his profile? Yeah, so and it again, these overhead projectors don't really do it justice. Things look much nicer here, though Ray looks nicer at any resolution. So, but things are it's not terribly sharp, certainly, right? The Swedish horses, dare say, look better, at least in terms of their sharpness on the screen. Ray, by contrast, no slight on his profile, it's just a little blurry, it's a little washed out. Because what file format is probably being used here? It is a video, but for this individual frame of the movie, what's probably being used? A JPEG or something like it. So within videos, you effectively have frames, literally like you have in a TV show or in a movie. Right? When you had the old reel projector, a movie is in fact just like a flip book. But the book is just so long and has so many frames that it really looks fluid. How many frames does a movie or does TV typically show you every second? 29.7, 29, 29.7, 30, give or take, usually around there, depending on the encoding scheme. But that is to say, literally, when you're watching TV or a movie, it's as though you're watching a really long flip book, but one that shows you 29 or 30 images within 1 second. And once you start to see that many frames per second, your eyes can't even tell that it's 30 different frames because your eyes just can't keep up. Your brain can't keep up with that, so you have the illusion of moving pictures. But think about it, moving pictures. What does that mean? Well, they're just pictures. They create the appearance of motion or of movement. So QuickTime is one file format developed by Apple for video. We mentioned another file format for video a little bit ago. What was that? So Flash is another one. So QuickTime, and this ends in .mov. Flash video, which you don't usually see this file extension because you yourselves don't tend to download these files. Rather, as you saw, they play in the browser. So these details are usually hidden from you, but they're usually .flv. Yeah. Sorry? Shockwave, we could put it in this category, but for now we'll keep it somewhat distinct because .swf files, the Swedish horses was a file called .swf. For now, let's just distinguish that ever so slightly by saying that's more of an animation format and not put it on this list for now. But you could make an argument there. What's another video file format you've seen? Yeah, so if you've watched this own course's lectures via the course's website, you've watched Real Video, whose file extensions, there's several, tend to end in .rm for Real Media. Real Videos were developed by a company called Real. How many of you have actually installed the Real software on your computer? So many of you, most of you, and presumably all of you who are tuning in from afar, at least with the Real Video versions. What do you get in this course with the Real Video versions? Sorry? So they're bigger, at least if you choose that bigger option. What else is interesting about the Real Video version of this course? What's going on over on the right side of your screen? So you have that split screen effect if you've tuned in that way. You have like a list of shortcuts to the 10-minute mark, the 20-minute mark, little things like that. But the slides are synchronized, right? We've started to move away from using slides and have been moving more toward demonstrations. But for the PowerPoint slides, they are roughly time synchronized. In fact, perhaps unbeknownst to you, every time we use a PowerPoint presentation here, there's a piece of software running on my laptop that writes to a file the exact time at which we change slides each time. So after each lecture, I actually email that small file to the video production staff, and they use it to synchronize those slides with the video, which is kind of a cool trick. But to play these real videos, you need special software. In fact, how many of you now that you have the Reel player installed seem to get little pop-ups in the bottom right of your screen from Reel telling you what's late and great and newsworthy? Anyone? Yes? No? So yes? No? All right. So those of you who do, you can get rid of all that stuff. Reel has long taken it upon itself. This is just a company, a multimedia company, taking it upon themselves to put a whole lot of stuff in software that at the end of the day, you probably only want to play movies in real video format. So for those of you who have PCs, I would actually recommend going to our course's website, going to the software link, and download something called Reel Alternative, which, needless to say, is an alternative, and it's sort of like a program that it's the bare bones. All it does is play the videos and the audio files, none of these pop-ups and news and weather and so forth that come with it. But the purpose for tonight is that Reel Video is certainly an alternative to these other video formats, and clearly using Reel Video, or the technology made by the Reel Media company, you can do other things, synchronization and timestamps and so forth, but you can do something else with Reel Video. And actually, you can do it with all three of these formats. When you start playing a Reel Video, those videos tend to be about 200 to 400 megabytes each week. How quickly do the videos start playing for you when you click on them? For the most part, right away. Maybe a 5-second delay, maybe a 20-second delay, right? There's that little icon, if you've seen it, that sort of says buffering or loading or something. Well, what is going on there? Well, if these videos are 200 to 400 megabytes, is your computer simply that fast? Is it downloading a 200 or 400 megabyte file within 5 or 10 seconds, storing it on your hard drive, and then playing it for you to watch? Probably not, right? Sort of a leading question. So what's going on? I hear that's streaming. So these three formats actually can be, quote unquote, streamed. So these are all streaming file formats, which simply means that you can start playing them before the files are downloaded in their entirety. Which is to say, when a program like Reel is buffering, or when a video is loading, even when you go to like Google Video or you go to YouTube, what those websites do is they start to download just a bit of the video, and then once they have a buffer of like 5 seconds or 10 seconds, then you get to start watching the video. And as you're watching the video, the program is ahead of you by 5 or 10 seconds, downloading the next 5 or 10 seconds. Sometimes, though, as beautiful as this setup is, what happens to you, the user? What do you see? Right? The video, it starts jumping or just stops, and then you watch some little annoying icon or whatever, and then eventually it starts to proceed again. Well, why in the world, if you buffer for 10 seconds and then start watching and you continue to buffer ahead, how could my two hands ever meet? So that's true. So eventually you will download the entire file. But my question for now is, why in the world, given this seemingly elegant design, would we ever experience what many of you have probably experienced, which is like the movie pauses for a second or freezes for a moment, for several seconds? Why can sometimes real time catch up to where the file is still being downloaded? Memory? Be more specific. Be more detailed. Okay. Not bad. It's not that type of memory that's so much at issue. A suggestion back here? So yeah, I mean, intuitively, that's got to be what's going on, right? The movie is playing faster than it's being downloaded, which is to say 10 seconds of buffering just wasn't enough. Well, at first, you only needed to wait 10 seconds to download 10 seconds of video, but you know as well as I do that sometimes the internet just slows down. right? Or there's congestion at routers. We already know that because of IP, routers can drop packets altogether. Well, if the packets get dropped and you're using TCP, for instance, to transport this information, what does TCP guarantee, did we say a couple lectures ago? It'll do what? Well, it'll retransmit that data, but if that data is going to be retransmitted, well, someone's got to wait for it, and that someone is you. And that's why sometimes these programs would stop. There's a difference here, though. Notice that all of the videos that we've been discussing, for the most part, are pre-recorded, right? We record them either right now and we'll put it online by tomorrow or Friday. The videos of the week that the teaching fellows have been shooting, well, those are produced each week, and then they're put online a week later in the entire volume. So what if, by contrast, you're trying to watch a baseball game live, or a presidential address live, or listen to it live? Well, similarly, can you tune in these days via the internet to live music or live video broadcasts? In fact, the groovy music that we tend to play at the start of lectures is the result of my pulling up iTunes, which is a multifaceted multimedia program today. If you've never used it before, it's fairly straightforward. On the left, there's a link these days to radio, and then you see all these different categories. And notice, what's the column described as here? A stream. So what is a stream? A stream is sort of an available feed of bits that you can tune into, and they're streaming in the literal sense. They'll start coming to your computer, but you're going to tune in wherever that stream currently is. And so in effect, what these are is online radio stations. And if I go to ambient here and choose, which one do we usually use? Oh, you usually listen to Groove Salad here in E1. I think this will be the last night you listened to Groove Salad, since it's starting to sound like this. But this is a radio station that is streaming itself over the internet. Those of you who like Boston radio, there are a number of radio stations even in Boston where if you don't have access to your car radio or your stereo, but you are sitting at work perhaps with headphones on your laptop with an internet connection, some of these local radio stations actually allow you to tune in via the internet, and they just stream out the information that way. An interesting thing to note is that there seems to be 3 different versions of Groove Salad here. What's the distinction among these 3 lines, if you can see the small print? Yeah, so kilobits per second. So good. Here, too, is sort of a building block from a few weeks ago. What does this mean if the one we're tuned into, per the little speaker icon there, is apparently has a bit rate of 128 kilobits per second? Finer sound. So the more bits per second, just intuitively, the more information you're getting, which means the better it sounds. That's true. And what does it literally mean if this stream is 128 kilobits per second? What is my computer doing each second? It's downloading 128,000 bits every second. And with a decent internet connection, that's fine. If instead I were on a slow internet connection, which is hard to simulate since we do have a pretty fast connection here, well, sometimes bits might get dropped, or maybe the server would get busy and it just can't keep up with the demand right now. So what might happen? Well, we could buffer again and again, but when you're talking about live feeds, like a presidential address or a baseball game, or really a radio station, which by definition streams in real time, right? It's not like TiVo where you download it and play it back later. Radio is sort of by nature real time. Podcasts, by contrast, are like offline radio, to make a simple distinction. Well, what would you rather happen during a baseball game if your whole purpose is in trying to watch this game live, albeit over the internet, or your whole purpose is to listen to the game live over the internet? Would you like your software to, well, wait 10 seconds, let me buffer, and then I'll show you what happened 10 seconds ago, right? It's a great way for you to lose bets. Right? If this is how you're tuning into the game, betting someone else who's watching live TV. So by contrast to a lot of the stuff we do in the course, which really you do not need to know about computers and the internet right now. Right? It's okay to wait until tomorrow. It's okay to wait 10 more seconds, 20 more seconds. But if you're watching something that by nature is meant to be live, like a baseball game or like a radio station or presidential address, well, you'd probably rather the software do what in those instances? Stream it, yes, but streaming just means deliver those bits in real time. But what's the problem? Server gets busy. Router starts dropping packets. So that's a clever idea. If it's just not possible to get all of those bits to your computer, what could you sacrifice? Well, you could just turn the thing off, right? Right? That's a wonderful way to compress the information. Just stop playing Bush's speech. Right, no comments. But what else could you do? You could just degrade the quality. And in fact, we see this here, even though it's not very dynamic, right? If I tune into 128 kilobits per second, that's the stream I'm going to get. And if you play this radio station long enough, you'll see eventually iTunes sometimes pops up a message that literally says, I think, buffering stream or something to that effect. And essentially, you just have to wait. iTunes does buffer for a few seconds just to give you that sort of buffer literally. So what iTunes does is, those of you with Discman, if you even carry around those ridiculously large CD players anymore, well, remember how they used to have, or still have, Shock Guard or something like that, where theoretically you can shake the heck out of the thing for 5 seconds, 10 seconds, whatever it tells you on the box? Well, what are those things doing? Right, those devices too are buffering the song, maybe 5 or 10 seconds worth of the song, so that if you're jogging or shaking the heck out of the thing, it can withstand that. But you can try this at home if you have one of these things, or maybe your roommate has one of these things. After 11 seconds, you start no longer to hear the audio. So CD players don't just degrade the quality, but radio stations, by contrast, might tune you down to a lower bit rate. Let's see if we can see the difference, hear the difference. So this is 128K. Good. You can really hear the difference. This is 24 kilobits per second, so an order of magnitude smaller. And even though if I had turned this on this way when lecture first began, you might still think the song is bad, but you might not realize that the stream is of low quality. But contrast this again now with... Okay, this song sounds bad at any bitstream, really. But the point, hopefully, is clear. So to recap, streaming technology just lets you watch a video in near real time, but if you're watching something that by definition is live, you tend not to just get this buffering effect. Rather, the song will degrade in quality, or what's one other option for a baseball game? Annoying as it might be, if your goal is to continue watching this game live, what's another option the software could do besides just degrading the images or the quality of the announcer at the game? Drop bits. And so what a lot of these streaming protocols and programs do is if they just can't keep up with you, you'll just miss that sentence that Bush just spoke, or you'll miss that save in the game because it's a trade-off. The designers of the software figure, well, this guy would probably rather we just forge ahead rather than get out of step with real time. Other video file formats that you might be familiar with. AVI is another one, and I'll jot this on the board. We won't spend as much time on here. You have a whole cheat sheet, if you would like, on your yellow sheet tonight. AVI is another older file format. Another popular one, DivX is popular. Those of you who deal in online movies or downloads thereof might be more familiar with that. MPEG. In fact, how many of you have ever watched an MPEG 2 movie before? 2 of you. 3 of you. Anyone else? Okay, we'll spin it. This is always going to be a trick question, right? So how many of you have watched a DVD before? Bam. All of you have watched an MPEG 2 video. So we've been talking all tonight about file formats. Well, all a DVD is a piece of plastic that has a bunch of bits, pits and lands, if you recall, stored on it. In what format are those bits? Well, DVDs use this format. And it's just a standard for video, and it's pretty high quality. But when you start talking about things like Blu-ray and HD DVD and all these things, for the most part, they're not necessarily just talking about differences in hardware. They're also talking about different schemes for encoding the bits. And what does that mean? It just means different options. Just as GIF and JPEG gave us different features, so do different formats for video give you different features that at the end of the day aren't as important to you, the user, because for the most part, when you, the user, pull up a website, you don't usually have choice over the format of the video. It's either watch this or not watch this, though some websites do let you choose the formats, including our own. But let's pose this one question about video before ending on a quick chat about audio. You've got a video. Clearly, these things are big. these lectures themselves are how large, did we say, in terms of videos, in terms of bits? Large. Good E1 answer. So this 5 seconds of awkward silence, how many bits did we just waste on those tuning in at home? So each of these videos, which clocks in around 2 hours long, less break time, are about 200, 250 megabytes. That is compressed. That is watching these lectures in 320 by 240 resolution at 32 kilobits per second audio. And it's a funny thing that this music sounds so bad at 24 kilobits. Well, and maybe I do myself sound bad at 32 kilobits, but voice does not need as high of a bit rate because I'm just not delivering that much information per second, so to speak. But how do you get away with using, it's up to you. Well, how do you get away with using fewer bits to store video? Well, what's the analog to our graphical world? Well, consider these movie frames. So suppose that at the top you have sort of a reel of film, and that film has captured the act of some RV driving past a house and a tree. Well, how in the world, if you want to show users that same reality, that same event, can you do it in fewer bits? That is to say, rather than keeping around a bitmap for every frame, can you throw away any of the bits? Well, what does the top reel of film suggest one technique is for compressing video? Good. So just like GIF sort of uses within one frame, within one image, this sort of cheat sheet and says, hey, that was blue, make the rest of this blue. Similarly, can you do that trick in video, whereby you have what's called inter-frame compression. Like an interstate highway goes within multiple states. Inter-frame compression goes within multiple frames. Well, if you already know from the first frame what the house looks like, what the tree looks like, why do you need to keep that information around again? And so what file formats like these tend to do to compress themselves losslessly is just throw away the stuff that we can just repeat from before. But there's a lossy approach, too, to inter-frame compression. What could you also do if you want to save space but still give a pretty good approximation of reality? Skip frames, right? The answer is right there. You can skip frames or drop frames altogether. Now, this doesn't mean drop half the frames and then show the video twice as fast, because that wouldn't fly too well. But think about the Frogger game that we saw before. That, in effect, had skipped frames, right? At one point in time, the frog is here. The next moment, when Heather clicked the up mouse, it then went there. But we didn't see anything in between. So in spirit, that's sort of like inter-frame compression that's just skipping frames. You don't know what happened to the frog between here and here, but your eyes and your brain sort of decide, he clearly went from here to here. Besides inter-frame compression, you can also do intra-frame compression, inferring simply from these two reels here, what is this very much like? Well, it's sort of like the previous example, whereby what's changing on the bottom reel, for instance, from frame 1 to 2 to 3 to 4? Right, in this case, there's no background, yes, but what that suggests is that we don't need it. We don't need the several thousands or tens of thousands of bits that might otherwise tell us what the leaves' colors are and what the petals' colors are. Why? Because the flower's not moving, the bee is moving. So in this way, could we similarly compress video, but in this case, are we losing information, or is this lossless? Lossless? Lossy? Lossless? Good question. When you play it, can you tell there's no frame there? It depends. It depends partly on how sharp your eye is, and if you slow the video down, you'll actually see, and you can do this with the course's QuickTime movies, just pause it, and then drag the little slider, and you won't see fluid motion usually. You'll see this. So yes, you can see it depending on the precision with which you can navigate the video. So I hesitated to say that this is lossless only because as of this frame, do we know what that flower looks like in its entirety? Well, I mean, as of frame 1, if this is the start of the video, just looking at this bottom reel, technically we don't know what is behind that bee, right? probably, just if we let our brains fill in the blanks, what is it? It's another pink leaf and maybe some more yellow to the center there. But that's interpolation. And we said this earlier. What can a computer do to sort of get the CSI effect and zoom in ad infinitum to the license plate? Well, it can sort of interpolate and guess, this looks like this and this looks like this. I'm going to guess that this thing in the middle is like the average of those two things. It's a little purple and it's a little yellow, and so a video could use a bit of lossy compression and just fill in those holes for us. It's ultimately a trade-off, but it's the file formats that decide how best to do this. A final note, we've looked at audio tonight. We've heard a bit of audio. Consider, though, the following. There are multiple types of file formats for audio. What is the one that most of you, or many of you, have probably downloaded before? So MP3s, right? This is sort of what's on your iPod, often, though not always. Apple has its own format for that. MP3s, this is what was popularized by Napster. If you weren't quite tuned in to what was going on or didn't really know much about computers and the internet back in the day of Napster, which was, like 98, 99-ish, give or take, what was all the rage was the sharing, illegal perhaps, of MP3s. MP3s, actually, as trivia, is MPEG 1 layer 3, though that's technical detail that is not terribly important, but this is only to say that it's related, even to the stuff we've been talking about. An MP3 is just a file format for audio. But the neat thing is that it's compressed, but it's lossy compressed. But, turns out, human ears, not so good. Which is to say, if you play a song from a CD, that tends to be, for the most part, uncompressed. So that's a bit of a white lie. But if you play an MP3, that's very much compressed. Consider this, and you've answered this question before. How big is a typical MP3 file? 2 megabytes, 6 megabytes, 10 maximally, at least for reasonably long or short songs. Well, a CD. We talked about CDs in lectures 1 and 2. How big is a typical CD? So it's like 700 megabytes, give or take. Well, how many songs are on a typical CD that you buy at the store? 16, I'm going to do easy math. Let's say 10 is typical, and that's kind of reasonable, maybe a little low. So if you have 700 megabytes available to you on a plastic disc called the CD, and you want to fit 10 songs on it, how big does that suggest each song is on a CD? Roughly 70 megabytes. That's pretty big. Downloading a 70 megabyte file is not so fast on a lot of internet connections, but an MP3 is how big, did you say? Roughly what? So let's keep the math simple. Let's say 7 megabytes, just as a rough estimate, right? So it's 1/10 the size of the original song. So what does that imply? How do you achieve a compression ratio of 70 megabytes originally to 7 megabytes afterward? So it doesn't sound as good because you presumably have to drop information. Intuitively, why is that the case? Well, if you're not dropping information, why was the original song 70 megabytes in the first place? What was it, just a bunch of zeros? Probably not. But again, the human ear, not so finely tuned such that MP3s, for the most part, are difficult for at least non-crazy audiophiles to distinguish from, say, the original CD version. I, for one, can never really tell the difference between a store-bought CD and, say, an MP3, a set of MP3s of the exact same CD, even though they're 1/10 the size. Consider this example. So again, we don't necessarily have the latest and greatest audio hardware here, but this is an MP3 of one of Enya's songs. It still sounds pretty good, even in this audio system, but it's 1/10 of the size that it originally was when I ripped it from its original CD. Well, how about this for contrast? Suppose that back in the day, we lived in a world where if you wanted to play music on your computer, what you heard was... So this is an example of what's called the MIDI file format. Those of you who are musicians and might have digital keyboards at home and compose music yourself, typically you're storing the songs you compose in MIDI format. MIDI essentially, M-I-D-I, stores the musical notes, A, B, C, D, and so forth, sharps and flats, in some kind of file. And then your computer just plays them back literally. Well, that's one thing, but if instead you want to actually enjoy the music you're playing, you can't just store all of the notes as notes themselves. Rather, you need, say, the MP3 version or a non-MIDI version that doesn't just represent each sound with an individual note, but sort of stores the information in the aggregate, and you have the same song, this time in a much higher fidelity version. Now we actually have a recording of actual strings and so forth. So your homework for this week, realize, is one, to familiarize yourself more with a bit of multimedia, particularly in your first banner and perhaps a mousepad project. And also do take a moment, if you haven't already, to pull up the course's website and tune in to the videos of the week, since those two are not meant to just repeat things that I may have said in lecture, but